Yeah, well, welcome back to the question 9. Question 1 through 8 has been done in the previous video. So we'll go to question 9. Check the question 9. Um, you realize that something is common there. Cos square x is there. Cos x is here. Okay, so we can divide through the equation by cos square x, whereby cos square x will go here. Here it will become sine over tangent. Okay, then here also will become tan square x. So I think by so doing, we'll be forming one trig ratio. Okay, so look at this, what we have here, question 9. We have 9 sine square x plus 10 sin x cos x minus 2 cos square x equal to 1. So divide through by cos square x. So whereby we're going to have here 9 sine square x here plus 10. This will go to remain 1, so that will be sine over cos x. Okay, then minus here, that will be 2 cos square x over cos square x. So this will go, and that will have 1 over cos square x. So this will be 9 sine square over cos square. That will be tangent tan square x, and this sine over cos, that will be 10 tan x. Okay, minus 2, and 1 over cos square x, that is what? That's sec square x. So if you check what we are trying to do now, we can see now we are tending toward one single trig ratio. Okay, so the only thing that remains now is for us to transform this one in form of cos and in form of a tangent. Okay, and that will be equal to 9 tan square x plus 10 tan x minus 2 equal to sec square x is 1 plus tan square x is an identity which says that 1 plus tan square x equal to sec square x. Okay, you can check one of my video. I think the first video on this trig aspect, it really explained in detail the trig identity, so you can watch that video for more on trig identity. Okay, so what we just did here is just for us to just plug in straight away, plug in for this sec square x. Okay, then you can move this one, the 2 item here, to the left hand side, so you can have complete quadratic expression, and that will be equal to 1 is here. If you go to the other side, we have 8 here. That's 8 tan square x plus tan x. Here we have minus 2. Here we have 1 here. Let me go to the other side. Minus 1 equal to 0. So we have 8 tan square x plus 10 tan x minus 3 equal to 0. So this has formed a quadratic equation, okay, whereby it's in form of tangent. So we can get the tan, tan x in this equation by substituting the coefficient of the tan into a calculator. Okay, that's so tan is 1 over 4, or tan x minus 3 over 2. So the general solution will be equal to x equal to, for tangent, 180n plus arctan 1 over 4, arctan 1 over 4, arctan 1 over 4, or 180n arctan minus 3 over 2. Let's check arctan minus 3 over 2. Arctan minus 3 over 2. Okay, so let's check that. So we're going to have now x is equal to 180n arctan 1 over 4, arctan 1 over 4, that's a 14 plus 14.04. degree. And the second one be equal to arctan minus 3 over 2. That's minus 56. That's 56.31. So these are the two general solution for this question, for this equation. Then what we need to do now is to get the list of solutions for the respective equation. For here, n equal to 0, we're going to have solutions are when n equal to 0, we have 14.04. When n equal to 0 here, we have negative, which is outside the range. N equal to 1 here, n equal to 1 here, we have 123.69. Here we have 194.04 when n is equal to 1. N equal to 2, this will be knocked out. It will be outside the range. But here we can have a value n equal to 2, that's 360 minus 56.31. And that will be equal to 303.69 degree. So these are the solutions for that question. Okay? That's the solution for that question. Then that will take us to the last question, question 10. Question 10. Sine 2 theta into bracket 1 plus 2 cos 2 theta is equal to 0. We are multiplying. Okay? We are multiplying. This implies that sine 2 theta is equal to 0, or 1 plus 2 cos 2 theta is equal to 0. Okay, so in this case now, we're going to solve this one, so that will be equal to, for the general solution for this, will be equal to 2 theta will be equal to 180n plus minus 1 power n, and then arcsine 0 is 0. We have 0 here, so it will just give us 2 theta equal to 180n. This will cancel out, that becomes 0. Okay, then we can have theta equal to what? 90n. That's the first equation. Okay. For the second one, this will be equal to 2 cos 2 theta. We can move this one to the right hand side, and that will be minus 1. So cos 2 theta is equal to minus 1 over 2. Okay, then we can get the general solution, which will be equal to what? 2 theta equal to 360n plus or minus arc cos minus half. Okay, and that will be equal to 2 theta. So 360 plus or minus, I think arc cos minus half is 120. Let's check that. Inverse of cosine, that's 120. Okay, that's 120. So theta will now become 180n plus or minus 60 degree. So we have these two equations, two general solutions. Okay, so let's tackle this. When n is 0, let's start from 0, because your range of values start from 0 to 360. So we have 0, n is 0, we have 0. N is 1, we have 90. N is 2, we have 180. N is 3, 270. N is 4, we have 360. Okay? Yeah. For the second one, for theta equal to 180 n plus or minus 60, let's check that. N equal to 0. Okay. We have plus or minus 60, but we're going to take the positive one there. That's 60, because negative is not part of the range of values. N equal to 1, we have 180 minus 60. Okay, minus 60, that's 120. It can also be 180 plus 60, that's 240. Okay, N equal to 2, that's 360, minus 60, that's 300. Because if you take the plus, it will be outside the range. So these are the values we have for the two equations. So if you like, you can arrange it, you can combine the two solutions together. So the solutions are the solutions we have 0, we have 60, we have 90, we have 120, we have 180, 180, we have 240, we have 270, we have 300, we have 360. But it's not compulsory that you combine it together so that you will not skip one of those values. You can just leave them after here and stop like that. Okay, and you get your full mark. So that's that on these trigonometric equations involving different ratios of the same angle. Please join the next video.